So we want the cutoff scores in order to come to a conclusion about the test, because that's how we make decisions. But if you want to know the cutoff score, you need to know the value of alpha, which is the probability of a type 1 error or false positive. We will talk about that later, but the terminology that I use is, of course, level of significance. For now, type 1 error comes in statistics, and I'll connect those later. For now, it's level of significance. And that is problem number 4. The information is coming up, but for each case, they want you to give the cutoff score for the comparison distribution. What is another name for comparison distribution? I wrote it in the notes. We can play the word game if you want. She's like, no, I hate that game. What's your name? Rachel. She was the first person to say no. Well, I'll play it regardless.
Sampling.
Very good. Sampling.
Lauren.
It's way off. Lauren said sampling. That is correct. Another name. Null. Null distribution. One more. I think I wrote another one too. Reference. Very, very good. I forgot your name.
Eden.
Eden. Okay. I should think of Jesus. Every time I look at you. Eden. That's how it all started, right?
I think so.
Yeah. I personally am an atheist, so I don't care. I would have grabbed the apple. So null distribution, sampling, reference, comparison, they're all the same. I'm giving you all the names just in case if you Google or get to YouTube, you might encounter this. So we want to know the cutoff score. That is what's going to help us make the decision. Hence, they gave that statement at which the null hypothesis should be rejected. I would like to add, it is not simply at. It could be greater than, less than. So it's not exactly one value. The next step is to find the z-score corresponding to a sample value. The last one is an assumption. Statistics revolves around certain assumptions. I'm not sure if you've heard this phrase before, but oftentimes people would say lies, downlies, statistics. Well, I would agree if you don't know what you're doing and if you're not ethical, right? Both of them are not acceptable. So ethics come into play and knowledge of statistics is important. I cannot take one procedure and just apply it to whatever test I know. One of research grants that I worked on, the other PI kept saying, oh, just use a t-test. And I said, no, you cannot, because your entire experimental setup violates t-test, or the assumptions that we have for t-test. So you would encounter time and time again assumptions for each test. A common assumption for a test that is or that uses z-score is that the sample and the populations are normally distributed, which means local. Okay, which is why we have that statement. Perhaps I will do a couple using the answer here. So we have 5 studies, arbitrary. They are considering or assuming a z-test. We have a mean, sigma, standard deviation. Sample score is what you get from the sample. And they have P. Now, what I used as alpha is referred to as P here. Do keep in mind, P value and alpha are not the same. Good. P value is an estimate of alpha. In social sciences, I've seen this in some articles. People would always write it as P less than 0.05. What they are referring is that the P value is less than 0.05. Formally, we distinguish by calling that alpha. But Earbot doesn't make that difference. It just calls it P, right? P is compared to a value for P. Hence, P and those 5 values, I can simply use alpha here as well. Okay, I'll do a couple and you can try CGE. So first, we need to have a normal distribution, which we do. 1 second. Based on the assumptions, the normal distribution will have a mean of 0. I'm telling you this. It has a name. It is a standard normal. In this case, I have to stress that part because we are talking about a specific case. Standard normal is denoted by the letter Z, uppercase, which is why we call it Z score cutoff, Z value for sample score, and so forth. For this distribution, the standard deviation is 1. We don't need that in this problem. They want us to use a mean of 10 and a standard deviation of 2 and 4. Now, formally, when you get these values from a sample, it's X bar and S. But since they are giving us values, we have mu and sigma. I will subscript it as Z sample score. The formula is X bar minus mu divided by sigma. That notation applies if mu and sigma are given to you. Those are the values that correspond to the mean and standard deviation in the population. That is a case which is not going to happen in practice. So we have mu, we have sigma. What is the value of the mean for the sample in study A? They've given us the sample score to be 14. In other words, that is the mean that we get from the sample minus 10, which is the mean, divided by the standard deviation, 2. Well, what do we get? 14 minus 10, 4. 4 divided by 2, 2. So the sample z-score is simply 2. Now, when we perform a test, we need to know, are we doing a right tail test, left tail test, or two tail test? They're giving you the tails. The first case, they say it's a one-sided test, hence 1. Within parentheses, they say pi is predicted. In other words, you have a sample, but you're hypothesizing or predicting that it is going to be bigger than what you have in your assumption. Good. So should we do a right tail or left tail?
Right.
Right, Harley, why?
If it's probably higher, then it should be to the right of the assumption.
So I'm predicting as the researcher that higher than what I keep as a reference. So I'm looking at on the right side. If this word was low predicted, you are looking on the left side. So high predicted, so over here. Visual, I'm not sure if this book does it. Again, I picked this textbook so that it's not too heavy on math. From last time, that area is a probability. What does that correspond to? What? I heard something, and that is the correct answer.
I said alpha.
Unless it says alpha, that is correct. What we call as alpha is what the table is giving as P. It seems like the book is going to use P as a notation, but I will keep stressing this as we move along. They're giving me a pointer 5. We need to know a cutoff. Well, from the table. What is the cutoff? When alpha is 0.25. I wrote this last time. I hope you have it.
1.6.
Very good. It is 1.645. Do keep in mind, if this changes, the cutoff will change. So if you keep on reducing the area, the cutoff will keep on moving to the right. Okay, we have the cutoff when we can provide evidence toward the alternative or the prediction. A high is predicted. The sample score is 2, cutoff 1.645 on the real number line, whereas the sample score 4. Here or there? Easy question. This does it fall here.
Yes.
Okay. I can simplify the notation. It's easier if I write it out. So the sample score falls in the shaded part of the real number line, which is the rejection region. Should I reject a null? So null means no effect. Alternative, there is an effect. Effect is what you test for. In this case, what are we testing for? A high is predicted. So is there evidence to support that there is a high market? Is it statistically significant? Yes. Why? So because the sample z-score falls in the rejection region at a p-level, alpha level of 0.05.
Don't we have to do that thing though with the p hat to find if it's significantly greater?
The p-value?
Yeah,
No, not in this case. We will do it in a real example. We will find the p-value. Since Riley put this up, I'll just mention it, but we'll write it. The p-value that you get from the sample is the area above the sample z-score. Just by looking at this, Riley, do you expect that area to be larger than 0.05 or less than 0.05? So the p you are referring to, the p-value is the area that is shaded in purple. Is that bigger than the area shaded in green or less? Less. So whatever the sample is giving us will be less than 5%, so we reject. Going back to the example that I did on anxiety drug, 3.44%, less than 5%. Don't have to write this. No. First, do we follow? So here, the sample is providing evidence toward the alternative that there is a high. That's study A. Going to underline. Hopefully, I will run out of space, but that's okay. Study B. Mean is still the same, standard deviation is still the same, sample score is still the same, P or alpha is still the same. The number of tails in this case is 2, yes? Which would make it a bidirectional test. My question to you, Hayden say high predicted in study B. Why? Right.
is it still about the effect?
Yes, still about the effect.
Well, I know that it's gonna be, the null will be at or equal.
Keep going. So what is the alternative? You kind of can help Riley out.
That they're different, or that they're not equal to.
Not equal to. Okay, so very formal answer, but based on what Riley said, why did they not specify high predicted here? Riley simply said, okay, equal means no effect. Not equal means there is an effect. Yes, that's it. Why am I not seeing high predicted here?
Because you have a positive and negative.
Very good. I could be on this side or that side. So intuitively, I don't care if it's low or high. If it's low, high, there is an effect, which is why they didn't specify. intuitively one can understand. So study B, I have to erase this and running out of space. We did write the formula, correct? So I'll keep space up here for the 5 studies. To draw the curves here, you'll have to draw separate curves. It is a two-tailed or bi-directional test. So no effect. Alternative, there is an effect, statistically significant effect. Previous case, high is predicted. Mathematical notation, it should be greater than. Over here, less than or equal to. As Riley mentioned, for study B, it will be equal to that. Not equal to. So if the sample score exceeds the cutoff on the right-hand side, I reject. If it goes below the cutoff on the left-hand side, I reject. So there has to be 2 cutoffs. But one on the left-hand side, one on the right-hand side. Naturally, one is going to be positive, the other negative. Agreed? One's below 0. First question to you. Can I use the same cutoff from last time?
No.
Why not? Go ahead,
Does it
Amelia.
say you have to divide it because you're splitting it?
Very good. I have 2 sides, so I have to divide the area. So on this side, it would be 0.025. That side, it would be 0.025. But when I wrote the table, I did the work and I gave you the values. Do we recall? You can look at your notes.
Approximately 2.
Savannah?
2.
Approximately, to the exact value is 1.95 or 9. So 2 minus 2. Will the sample z-score change for study B? Riley says no. Do we agree with Riley?
Just divide.
We'll divide what's Savannah. So we divided the area. We did that part of it. So my question is, will the sample z-score that we computed for the previous study change? No, can't be.
No.
No, Rachel says no, because mu is the same, sigma is the same, sample score is the same, doesn't change. So these 2 values are the cutoffs. The sample z-score that we had was 2, exactly 2. So this is a tricky situation because the cutoff falls right on top of the, backwards. Sample score falls right on top of the cutoff. Now, numerically, I know from experience that the cutoff is slightly smaller, but doesn't matter. If the sample score falls exactly on the cutoff, or if it goes past it, we reject. So if it falls right on top of it, or exceeds, same here, right on top of it, or below, we reject. In practice, though, this is a very borderline case. This is a case where you need further investigation because you're right at the border. So you need more analysis. So based on this picture and based on what I said, can I reject the null? Yes or no? To make that correction, I'm going to write H2. Yes or no? Elicited by they say yes. Good. Now, the verbiage that I use is not going to change for study C, D, E. If you want to write it so you can understand better when you get home, fine. Otherwise, all I need to see is the notation. What will go here, there, there, and what is your conclusion for study C, D, and E? In order to do that, you need to know the cutoff values. I wrote it last time. Do we have it in our notes? I believe I wrote it for 0.05, both unidirectional, bidirectional. 0.1, both unidirectional, bidirectional. 0.01, both unidirectional, bidirectional. Slide. Did I write all three?
I have the score cut off for 0.05, 0.01, and 0.25. And then the sign level. Oh, yes. You're right.
I did write.
Except
Let's
for not
double check.
0.02. I just don't know.
0.05, 0.1. Okay, I read the business in the direction of that direction. Good. I did write the value, so you should be fine. Look in your notes, look at the cutoffs, and obtain the conclusion for studies C, D, and E based on the information that's given. Give you a few minutes for you to try and try, that's how you learn.
It's all for teaching.
Okay. So what conclusions did we obtain for C, D, E? Not reject for all three of them? That's what this says here, okay? Is someone agreeing, disagreeing? Savannah says the same. Now, I did this part to show the connection between area and the rhythm of the line. This curve is the optional part. If you make the connection between the area and coming up with the cutoff, that's all we need in this class. So once you get the idea, you can not do this. Yes, keep things simpler. Only after you get a good understanding. Until then, draw it up. Assuming that you got a good understanding. Part of study C, alpha changed. If alpha changes, will the cutoff change? Yes. Did the study sample score or the sample score that we computed, will it change for study C? No, because the mean is the same, standard deviation is the same, the sample score is the same, so that will remain same. The next step is to look at the type of test. This is one tail test, unidirectional. It says high predictive. Null always means no effect. Alternative, there is an effect. You are testing for the alternative. It says high predicted. So what sign would go here? Right, so what sign? The greater than, less than? What's equal to?
Greater than.
Greater. So the rejection rating is going to be here. If you refer back to the table for a unidirectional test, when alpha is 0.01, the exact value is 2.32. I approximated it as 2.4. When you do my make sure that you use the exact values. Sometimes it's you can find that table in your textbook. It's in chapter 4. They have summarized it. So for study C, if the sample score exceeded 2.4, I'm going to reject the null. The sample z-score did not change, it is still 2. So that falls right here. Yes, no, maybe. Should I reject? No, I shouldn't reject the null. If I don't reject the null, the opposite of that is less than equal to. The data or the sample study found evidence against the predicted hypothesis. Good. So there is not enough evidence to support the hypothesis. Are we clear? Yes. Same principle, no effect. Effect, all I have to do is determine the sign. Study D. What sign goes here? Not equal to, which would mean the opposite, and the null equal to. Two-sided. So I will have a cutoff on the left-hand side, cutoff on the right-hand side, negative on the left, positive on the right. However, it will be the same value. Why?
You have to break it up into two.
You have to divide by 2. I wrote this a couple of class periods ago for a bidirectional test when alpha or the p is 0.01, the corresponding cutoff value is 2.58. Positive, the 2.58. Yeah. Always all the things.
We had 0.01 for the last one, right? And it was 2.2 or 2.4.
Yes.
When you cut 2.4 in half?
No, you cut 0.01 in half. So it's 2.58. Do check the textbook. I always increase this one because it's not used in practice. Also, 2 is here. If the sample Z score fell over there or here, you would reject the null. Did it? It didn't. So we have no evidence to support the alternative. We're going to stick with that. No effect. Good. Very last case. First question. Can I use the same sample Z score? Sarah says, no, why not?
There's a different signal.
So all of these were 2 for A, B, C, D. E is different. So that would change the sample Z score. The formula for that again is X bar times mu divided by sigma. X bar is still 14, mean still 10. However, sigma is 4, which will give me 1. Yes, I do have to change this picture. Why? I have to change this. Why?
It's not bidirectional.
It's not bidirectional. The P is 0.25, and we know for a unidirectional test when alpha P is 0.25. That value, the cutoff, is 1.645. 1.645 and above, you reject. Otherwise, you don't. So where does it fall? The samples at school? Somewhere here. It's just that an arbitrary position doesn't matter.
That's why I cut off those references in this chart. That's
Did the samples at school fall in the rejection region above the cutoff? It didn't. So I have H0, H1 greater than because high predicted less than or equal to no effect because I do not project the null. Are we clear? Yes. So until you get confident with the process, I strongly recommend writing stuff out and drawing stuff out. After enough practice, you can do this in your head. The ultimate goal is to come to the correct conclusion. Good?
I have a question.
Yes.
How did you get 2.58 for
From the table that I wrote. Is it not 2.5?
It is.
Yeah.
It's just.
We round
So
it
you-
to 6.
I rounded it to 2.6.
Yeah.